Okay, so last week we did not have classes because of the testing days. Um, I did go ahead and put up the second part of the organic chemistry notes. Um, so we can go through that later if we need to, but I want to talk about kind of what's up here for the rest of the year. So basically for the last couple of weeks, I have given you guys just a little project to work on. So we're not going to be doing any more new information. And so the project relates to kind of the basics of like organic chemistry. So the names, the formulas, the different functional groups that you guys have been kind of learning about the last week or two. And so let me go to the actual project. Okay. So I'm calling it We Are Family because everybody has been assigned a family of organic compounds. So I put everybody's name in like an online generator and I just had it generate you guys in a random order. And then I kind of just went down and did the functional groups or the families. So if you click on this link, it'll open the spreadsheet with the list for you to look at, hopefully in just a second. So let's see, where's Precious at? Precious, you have halogenoalkanes. And you have alcohols. And Areli just came in. Here she is. Areli, you have ketones. So that is the family of organic compounds that you're responsible for focusing on. Let me go back to the assignment. So this kind of goes over what you should include. So you want to include basic information. So like what's the name? So obviously like, if you have alcohols, you want to make sure that you have alcohol on it. What's the formula of the functional group? So like, what are the elements that are involved in that functional group that make it that family or that class? How would you recognize it? Talk about some of the properties. So all of these different families have different properties. Some of them are, known for like all their molecules are nonpolar, or some of them are polar, or some of them are used for different functions, different things. So think about what properties are discussed that you could include. And why do they have those properties? So like what about their bonding or what about their structure makes them have whatever property you're talking about? For name and formula, these kind of might go together. It depends on depends on how you want to set it up. For name, you want to include the pattern for naming it. If you're given the formula structure, so if you're given a picture of the chemical structure, how would you write the name for your family of organic compounds? And you want to have at least 2 examples, so 2 different molecules with you showing how you would write their names, or how you write their names from the structure. Okay. For the formula, if you're given like the name, you want to be able to show how would you represent it with all the different types of formulas that we talked about. So like what would the empirical or molecular formula look like? The full structural formula, that's the one where it has all the bonds drawn and it shows all the hydrogens. The condensed structural formula is where it shows us all the letters, but it's condensed. There's no bond lines, unless there might be a double bond maybe. And then the skeletal formula was the one where it doesn't show any letters unless there's like an oxygen or a nitrogen. But all the regular carbons and hydrogens are not shown. Only like if you have extra functional groups with other elements that you'll add their symbols in. So at least one example for each of those formulas. Okay. You want to relate the word homologous series to your family. So in our notes, we talked about what a homologous series was, like the basic definition. So you want to talk about kind of basic what it is, but that also give examples, at least 3 molecules from your functional group family that show a homologous series. So you're going to kind of tell me what homologous series is, but use your family or your class of organic compounds to illustrate what a homologous series would look like, okay, with the formulas and the names. Real world examples. So what is your family of organic compounds known for? So a lot of them, if you do some research on the internet, they have a lot of different varied uses. Some of them are used in medical things. Some of them are in biochemistry. Some of them are used in like oil and petroleum. Some of them are used in manufacturing processes. Some of them are used in like refrigerators. Some of them are used for all kinds of things. So what are some of them give flavors and scents to certain foods and certain like perfumes and odors and things like that. So what is your family of organic compounds known for? And like where can they be found? What are they used for? Why? So kind of those are some questions to consider when you're looking for some examples of real world uses or real world applications of your family of organic compounds. And I want you guys to have at least 2 different compounds and their uses. Okay. You can use any online or paper resource. I highly suggest you use something digital because that makes it a lot easier. Canva and PictoChart are really good sites that I've had people use for other projects earlier this year with really good results. You can use Google Slides. However, I will caution you that is not the best option because Google Slides is very limited in, like the backgrounds and the images and things you can do. So just make sure that you're kind of keeping in mind, this is a infographic. So this is it's like you're making a digital poster. It's just one page. So if you do use Google Slides, it cannot be multiple slides. It's not a presentation. It's just a like digital poster with all this information on one page or one slide. So when you're finished, you will upload the file, image, or link. So if you do it like Canva or PictoChart, you should be able to save the file of your finished product, and you should be able to upload that file here, okay? Or if you do it on paper, you should be able to scan it using your scan app that you've been using for notes, and then upload that file here. And then everything below this, it really just goes over some more information. If you're not, like if you've never done an infographic before or you're not sure what it is, it's going to give you some guidance. So there's a little video here that just goes over like 7 of the most common types of infographics. This is by no means all the possibilities. These are just 7 really, really common ones. So if you're not really sure what you're supposed to be doing, that video might help you, might give you some guidance on like which direction you should go in. And then also number 6 here, below the instructions, I put an example of a visual article and a comparison. So the visual article is honestly probably the closest for what you guys are probably going to be doing for this assignment. Because visual article means that it's got visuals, it's got images and pictures, because you're going to have pictures of like your chemical structures or your example, maybe your real world examples or something like that. But then it's an article because it has information and text as well. So this one right here, this is a visual article. And so whether it's a visual article or if I go over here and I show you the comparison, so, obviously I can tell this is a comparison because it says bad posture versus good posture. But on both of them, even though they're set up differently because they're trying to accomplish different things, this one is really just informing us about crime scene chemistry and fingerprint detection. This one is comparing 2 different things. But they do have like their main components in common. So if I click on these little green pluses, you should have a large title that is easy to find and read, and it should relate to what you're doing. It shouldn't just be some random title. It should tell me what your topic is and what I'm going to be reading about on this infographic. Then you should also have subtopics. You don't want to just put all the information everywhere. You want to have it organized so that it's easy to follow, okay? So usually you use subtopics. So the subtopics, you could use headers, images, border, it's really anything you think of, but you want to clearly show like where are your subtopics within your major topic. So for example, with your organic compound family, one topic's real world examples. So when you include the information, it should be clearly visible and organized. Like I should see a section where I'm going to find the real world examples. I shouldn't have to like hunt for it. So it doesn't have to be structured like exactly like this example on this page. You can arrange them however you want, but in general, it should have some type of organization to it, okay? You should have images, okay? Because on your directions, I told you guys that you have to have chemical structures, okay, for your functional group family, okay? And then you might also include something that maybe relates to the real world examples, okay? But you need to have multiple relevant pictures that explain it, and they shouldn't distract. They should relate to what you're talking about. So it says if you're working on the names and formulas, you should have a picture of the structures in that section, okay? And you should relate it to the names. It should have text that goes with it. Like right here, they have this little image that says pigments, and it's got these pictures of these different elements and their colors. And if I click, there's text below it. There's a short image description to clarify what the image is or why it's included. So they didn't just randomly put these here. They put them, and then below it says it includes aluminum, zinc, and all these other powders and carbon. So they're telling me these are the elements that are in latent fingerprint powders that give them the pigments. Okay. And then you want to have text. So text to explain your subtopics. Do not copy and paste stuff from the internet. You can do research, but you should be able to translate it into your own words. And you want to try to make it reader friendly. So like pretend you're making this for your English teacher who knows nothing about organic chemistry, or pretend you're going to present it to your parent or your sibling who knows nothing about organic chemistry. So take the information you have and make it, translate it in so it's a little bit more reader friendly. Okay. You're informing new readers. That's the purpose of an infographic. I already know this information. So you're not informing me, you're informing people who don't know about it. So keep that in mind when you're designing things. So I'm not going to go over the comparison a lot, but it does have all the same parts. So I can hover over these little plus signs. It has the same things. It has title, it has subtopics, it has images, it has text. Everything is the same. It's just arranged differently because the infographic is doing a different job. Okay. Let me go back up here. So for more infographic inspiration, really honestly, look at this website, Compound Interest, and I'm going to show it to you in just a minute. They have tons of infographics that are like kind of you can use for inspiration. You have to have all those components marked with the plus sign. So make sure you kind of go back and look at that if you need to. And then there's also a rubric down here, tells you how much points everything is worth. So the total maximum is 20 points. So you can get 3 points for having your main topic identified, clear, easy to identify. It's complemented by appropriate images or text to introduce the topic to readers. Subtopics, up to 3 points for having the subtopics, easily identifiable and they're present. 3 points for all your visuals and images. So you have images and they represent the information appropriately. You didn't just like throw random pictures in there and not tell me what they were for. Your information, up to 5 points. So all your information is clear. You support the main topic or subtopics. It exceeds expectations. You go beyond the requirements, all that good kind of stuff. Okay. 4 marks is going to get you, where you're doing everything and you're supporting your topics, but it didn't go like the extra mile. And then the last two kind of have to do with aesthetics. So grammar and spelling, and then design and layout, 3 points for each of those sections. So make sure that you check for grammatical mistakes, spelling errors when you're typing your information. Make sure your design's neat, clear, and visually appealing. Okay. So if it's hard to look at and hard to read, you're not going to get full points in that last section. So basically, you're going to have the next 2 weeks to complete this. It's due on Friday, the 9th, the 21st. And it is going to count for our last test grade for the 6 weeks. Okay. Before I kind of take any questions or anything, so I'm going to go. Okay. So where'd it go? Oh, all right. So this is that Compound Interest website. So if you click on that link that I put, it'll take you here. And they literally, all of them relate to like science and chemistry. So they're really good to look at. It's like, here's one, it's like the chemistry of laundry pods. Here's the chemistry of tulips and tulip fingers. Here's 12 women in chemistry. Chemistry of the World Cup, the science of thunderstorms. Structures of neurotransmitters. Here's like glassware for labs. Periodic table element name origins. Recycling rates of smartphone metals. So there's, again, all kinds of different ones here, and you can go here to the index and you can look at like a specific like subtopic if you want to. But these are really good because they have, text, they have visuals, they have, they're organized neatly. They have kind of the subtopics with the headings organized nicely. All the images tie into the text that's on presented on there. They're color coded a lot of times, just kind of depends on what it is. But so here's some down here. Like I can probably find one. Let's see, is there organic chemistry on here? Inorganic chemistry. Here's organic chemistry. So if I click on organic chemistry, so this guy, he is the guy that did work to help to figure out the structure of the benzene ring. And so this one talks about the benzene ring and the p orbital overlap for the double bonds. Okay. Here's one that has all the functional groups. Look at all of them. Okay. And we haven't even talked about all of them yet. But this has the basic, just the all overview of all the functional groups. You're focusing on just one functional group on your paper. Okay. Here's one that focuses on this one chemical, 2,4-dinitrophenylhydrazine, its risks and uses. And so it has the structure, so you can see the images, the elements are different colors. They go over, here's the text, there's some subheadings here. What's it used for, and how do you store it correctly and safely? They've got some images here for like the warnings for safety. So these are kind of just some more guidance or explanation. Okay. Here are some that, here's another one to organic compound names. Okay. So again, take a look. There's a lot more on this website. I just clicked on like one category. There's a whole bunch more. Okay. Biochemistry, chemistry history, chemical reactions, chemical warfare, colorful chemistry. So you can look through there just for more kind of inspiration. But that is what you guys are going to be working on pretty much for the next couple of weeks, because I know a lot of you guys last week started taking like AP and IB tests. Some of you have more this week or maybe next week. So I wanted to make sure that we kind of finished up any information last week with just the beginning of the organic names and formulas. And then I'm really just going to give you guys the next couple of weeks to work on this. And then after this, the only thing will be our final exam on our last day on the 24th.